Alright guys, good afternoon. This is going to be some more Chapter 4 problem work just so we can get some good practice in it. The problem I have right in front of us is a Chapter 4 3D problem. It's 4.117. It should be in your book. So this problem, I'm not sure he has given it for you in homework yet, but this problem is a really good problem that he could do for one of the harder Chapter 4 questions in Exam 2. This problem, it kind of takes a while, so definitely if he gives you something like this on the exam, um, really make sure you know how to work the problem out, and if you find any ways to do it a little bit simpler, a little bit quicker, of course do that, but just make sure you're doing it correctly. So, going right along with it, homework 4.117 tells us that we have a 100 kilogram uniform rectangular plate is supported in a position shown by the hinges A and B by a cable DCE that passes over a frictionless hook at C. Assuming that the tension is the same in both parts of the cable, determine A, the tension in the cable, B, the reactions at A and B, and we also are going to assume that the hinge at B does not exert any axial thrust. So to start off, this is the diagram that is given in the book. I just redrew it so we can see it in this problem, in case you don't have the problem in front of you. Starting right on along, we'll go to the free body diagram. So the free body diagram, we have the hinge at A, which exerts all three forces. You can state the y direction to be positive up or negative down. I say it is the way, because what you do is when you put your reactions at A and B, you're assuming a direction when you're putting these reactions. So for this problem, I assumed because it's kind of like hanging, the tension's holding this kind of plate up, I assume that the reactions are going to be down, at least in the y direction. So I have AX, AY, and AZ, AY being negative, and BY is going to be also negative, and we have BZ, we have nothing in the BX direction. We have our weight of the plate, which is our G global of the weight, it's acting at the center, and they gave us the weight as 100 kilograms, but we need to convert that into newtons. So we get 100 kilograms times 9.81 meters per second squared. We get our weight to be 981 newtons. For our tension in the cables, we'll just state them as tension CD and tension CE going to those points, but we won't draw it up fully because we're going to break this down in kind of a component form. So the free diagram, if you start drawing too much, it might get confusing, so I just drew them really quick and short just so I know what's going on. So to start off the problem, we're going to look at our length AC. So that's going to be 690 millimeters in the X direction, plus 450 millimeters in the K direction. But also note that the hinge is 90 millimeters from the origin. So we have to take that in consideration. So we have to subtract it from our beginning to get our length AC to be 600 millimeters I plus 450 millimeters K. Now we can do the same thing for our length AG, which is going to be 690 millimeters I plus 270 millimeters as well in the I because it's all added up together. That's a total distance over 2. Now we have 450 millimeters in the K direction over 2, so we got to find that in the center. Keep in mind that the hinge is 90 millimeters away from the origin, so we have to subtract that again. We get length AG to be 390 millimeters I plus 225 millimeters K. Going right along with it, we get our lambda CD, which is equal to tension CD in vector form. Multiply those together, do our sum of forces. So we're going to have tension CD is equal to negative 690 millimeters I plus 670 millimeters J minus 450 millimeters K all over the square root of 690 squared plus 675 squared plus 450 squared. So we'll get our length CD to be 1065 millimeters. doing the exact same thing for tension CE, doing that same sum of squares, we get 270i plus 675j minus 450k over the square root of 270 squared plus 675 squared plus 450 squared. We get our length CE to be 855 millimeters. Now we can do our sum of forces in the x, y, and z. We get AX minus 690 over 1065 times tension CD plus 270 over 855 times tension CE is equal to 0. Sum of forces in the y, we get negative AY minus BY plus 675 over 1065 times tension CD plus 675 over 855 times tension CE minus our weight. Forces in the z direction, we get AZ plus BZ minus 450 over 1065 times tension CD minus 450 over 855 times tension CE is equal to 0. Feel free to pause the video so you can catch up for that, because I kind of went through a little quick. Keep in mind that I'm keeping all of this in a component form because it's just a lot of dimensions and a lot of placements to be thrown at you. So looking at our sum of forces, we have plenty of unknowns. We have up to 4 unknowns in one of the equations. So we need to take a moment. If we take a moment about A, we get our length AC times tension CD minus length AC times tension CE plus our length AG times our weight is equal to 0. So if you break those points down, you'll get 600 millimeters I plus 450k times, and this is this right here, the negative 46 over 71. I broke them down into our sum of squares over the 270, so negative 690 minus 675 minus 450 all over 1065 is broken down into these points right here. But when I use a discriminant method, I'm going to break them back up into these forms to make it a little bit kind of like a straighter path for it. So continuing on with it, we get minus our length AC, which is 600I plus 450k, times our tension CE. Again, I simplified it down from doing that over the total distance I found, which is 855. But in the discriminant method, I'm going to keep them back into the original component form. So you can, if you would want, to rewrite this in the component form from back up here, which is our length TCD over here and TCE right here. And then our AG times our weight, which is 390I plus 225k minus 981 newtons. Now this is a lot to do. If you want to do it using FOIL method and breaking it all down, you can, but it's going to get pretty lengthy and pretty confusing. So the easiest way to do this one would be using discriminant method. You could also try to do it in a matrix form, but the matrix is going to get kind of confusing unless you know linear algebra or numerical analysis. And being that this is just statics, beginning portion of engineering college, that it's safe to assume that those courses are going to be a little far on the advanced side. So we're going to use discriminant method using algebra. So we're going to break them up into ij and k, which is going to be 600, 0, 450, and then negative 690, 675, negative 450. All of that times our tension CD over 1065, which that would end up being what I did right here, if you really wanted to break it down in a component form, but it's easier if you just keep it like this. Plus ij and k of 600, 0, 450, and 270, 675, negative 450 times tension CE over 855. Plus ij and k of our weight, which is right here, 390 0, 225, 0, negative 90, 981, and 0. And then we also need to keep in mind of our forces in the By and the Bz right here. And discriminant methods, so we have 780, 0, 0, 0, By, and Bz. Again, that's a lot to kind of like just throw down, so feel free to pause the video and really pay attention to where I'm getting these values. Now when you're just doing the discriminant method, you're going to break them up into its I, J, and K format. So for example, if I'm going to go in the I directions, I'm going to cover up this column and this row. So when you do that, you're covering up this and this, so you only have these values right here to worry about. To do that, you're going to take in this form right here, which is AB over in CD. You're going to do A times D minus B times C, which is this equation right here. That is how I'm getting all of these values that you see right here. So to break it down, for our first portion, looking at in the I direction, we block off this and we block off this. So we're going to have 0 times negative 450 minus 450 times 675. All of that times tension CD over 1065. To the next portion, we're covering up our column I and our row. We get 0 times negative 450 minus 450 times 675 times tension CE over 855. Same thing for this one over here. We get 0 times 0 minus 225 minus 981. Now on this portion, when we do it on this section right here, we get 0 times that times minus 0 times that. So all that becomes 0, so I don't even write it down. Simplifying it all down, we get this equation right here, negative 475 times 675 times TCD over 1065 minus 450 over times 675 times tension CE over 855 plus 220725, which is just this value right here. Now recall that tension CD is equal to tension CE, given to us by our givens from the problem. That tension CDE over frictionless hook, assuming that the tension in both cables are the same. So that's why we did it in that way. Simplifying it down, we pulled out our tensions. We simplified these values right here. Move this to the other side. So we get tension times negative 320,625 minus 320,625. Both of those are the same integer, negative and negative, so it's going to be greater. Then we divide that over this. We get our tension CD is equal to tension CE, which is 344.64 newtons. I went ahead and rounded it to 345 newtons. So now we're going to do this same process in the J and the K directions as well. So if you do it in the J, you're going to mark out this column, but the first row again. So now you're going to have 600 times that minus 450 times negative 690. So doing that in the same format, we're going to get this pretty big equation right here. Feel free to pause the video so you can write this down, because I'm going to be kind of moving around along. To save time, I'm not going to start saying all these numbers again. I'm just going to keep just kind of pointing at them and moving right along. So after writing this equation, we can get it simplified down to 40,500 times tension CD over 1065 minus 39,500 times tension CE over 855 plus 780 times BZ is equal to 0. Simplifying that all down and solving for BZ, we get our reaction BZ to be 185.7 newtons. Same thing in the K direction. We do it in the K direction. You're blocking off this column in the first row. So we get 600 times 675 minus 0 times negative 690. Following that same pattern for all of the values given to us from our main discriminant form up here. Simplifying it down, we get By is equal to 40,500 times 345 over 1065 plus 40,500 times 345 over 855 minus 382,590. all over negative 780. We get By to come out to 112.8 newtons, or you can round it to 113 newtons. I just kept it out to that first decimal place just because I wanted to keep my numbers kind of more accurate. So now you have the discriminant formed down, we can take our sum of forces in the x, y, and z back from what we studied at the beginning and start plugging in and solving. Solving for ax, ay, and az, from up here we get ax is equal to 114.6 newtons, ay is equal to 377.2 newtons, and az to be 141.7 newtons. So this problem is a lot to work with and a lot to watch out for. And if you feel like that I went a little too quick, don't worry, don't get discouraged. Remember, it's a video, so pause the video at any point, try to catch up, see what I did, and try to figure out which way I was going. The discriminant method, this method is probably something that Jackson hasn't gone over too much, but to break this problem down in all of these components, this was one of the easier ways I could do it to show in each possible step. The discriminant method that we use in here, I think, is probably the later part of just regular college algebra, or if anything like pre-cal or cal 1, but I don't think cal 1 really does this, so it's mainly just algebra at this point. That or like linear algebra. It's really good for linear algebra is actually what this one is. So if you don't know this at all, don't feel like you had to go and teach yourself linear algebra. You don't. Just know basically how the discriminant method works using this form, and it will be a little bit easier to kind of work with it. So if you have any questions, again, feel free to shoot me an email if you have any questions on it and don't understand how I got some of these numbers. And other than that, we are done. Pay attention for the next videos coming up.